Everyone, welcome to ITS 450 Software Assurance. Today we are going to look at the very last lab for the semester, which is the cross-site request forgery. Okay, so start that lab. I also want to remind you that you should be working on your term project and that in fact you are doing a second set of demos this Thursday, correct? So very similar to what we did the first time around. I'll be looking to see where you are, giving you some feedback. We're gonna do breakout sessions, and then we're gonna, take a look at where you are. So be ready for that, okay, please. Are there any questions about the project demos on Thursday?
Professor, I do have a question. Is there any specific portion you would like us to have done by Thursday? Like
Well,
having checkout done or something?
Yeah, checkout, you need to be close to being done because after checkout, there's still quite a bit to do. Right? And so with the breakouts, it's like I'm gonna be sitting with your group and I'll take a look at it and I'll again point out the things that, I'll ask you questions, point out the things that I would like to see. Remember, this project is not about developing something from scratch, right? Instead, it's about assurance, so quality and security, so making sure you got the code to work without errors and also that there are no vulnerabilities. Make sense?
Yep, that makes sense. Thank you.
Okay. Yeah, so don't forget that on Thursday. Additionally, so on Thursday, you'll be working on that. Plus, you can also work on the cross-site request forgery lab. As you know, I believe the cross-site scripting lab, we went over that one on Thursday. So you can also ask questions about that if you have them. That one, I believe, is due Thursday night. All right, as you know, we are getting close to the end of the semester. Next week is Thanksgiving, basically, so it's a short week. And today, as I said, we are covering the very last lab that I'm going to have you guys do. So this is your last homework assignment. After this, all you have left is the project and the final exam. We may still do a few lectures, which will just be like miscellaneous topics, little things here and there, kind of to wrap up the semester, but I'm not going to require you to submit labs anymore because I really do want, you should be focusing on your project, your term project. Remember that the project is not just about the code. You should also do the documentation, the testing, and everything, as we have discussed in previous lectures. All right, so you should be seeing on my screen, you should be seeing the slides. Okay, so I'm gonna bring up the slides. Okay, so this is the last lab, as I said, that we're gonna cover this semester. It's the last lab related still to web security. So far in web security, we've talked about, same origin policy, SQL injection, JavaScript injections such as cross-site scripting, basically implementing a self-replicating worm, which is what you're working on. And today, we're going to start the cross-site request forgery, or XSRF. So this one, actually, I would say it's one of those attacks that always, there are some attacks that, I teach this class every year, and I always remember what they are exactly. This is one of those that sometimes I have to remind myself of how it works. And even though I've discussed it many times, and it's really because it's a little bit not straightforward, I would say. It's not 100% straightforward, but if you think about it, it should make sense. So, oops. Okay. So today the plan will be, I'm going to basically go over the slides and kind of give the intuition of the problem, how it works. Remember that a lot of these things are always geared towards the lab, so I'll be mentioning the lab quite a bit. And then after doing the slides, we're gonna switch over to the PDF. We're gonna look for the latest XSRF document on the Seed Labs website, and we're gonna basically think about what we want to accomplish with this one. All right, but it is part of web security. So as you might imagine, it's another type of code injection where the simple countermeasure or solution would be some type of input validation. Here we also have the notion of tokens, because this is very much a communication type. It's sort of a authentication related. So when we talked about WebSOP, and because you guys have taken 362 and 110, you know a lot about the document object model, and you know about cookies and everything in a web page. So those ideas once again come back. Once again, same origin policy comes back. All right, and we're going to basically explore this one as well. All right, we are now ready to begin our discussion of cross-site request forgery, or CSRF as well. All right, so this CSRF attack involves, and that's why I keep saying this one is not so straightforward to get it in the beginning, and that's why I kind of have more of a write-up there, kind of give some ideas, and so that we can start to lay it out. So the cross-site, a CSRF attack involves a victim user. You think about it, a victim user, a trusted site, and a malicious site. Okay. So the victim user holds an active session with a trusted site and simultaneously visits a malicious site. The malicious site then injects an HTTP request, which could be a GET or a POST request, to the trusted site using the victim's user session, and therefore compromising the integrity and the authentication of that connection. So the classic example of this, let's say you're a successful executive in a company, and you're sitting in your your corner office on the 50th floor or whatever, right? So you're there, kind of have your back towards the glass, and you open your laptop and you log into your bank. So you're checking your, it's the end of the month, you're checking your salary, etc. Someone in another building, and also I shouldn't forget, you're using, because it's really important, you're using, let's say, Chrome or Mozilla Firefox or Edge, one of those, one browser, a browser. You have your web browser. You have your email open. Say you're using Gmail, and then you have your bank open on the same browser. Then somebody from another building, they're looking at you with their binoculars. They have their high-powered binoculars. They're looking at what you're doing. And obviously when you typed your password, they couldn't see that because, that does show, but they have people that used to work for the bank. So the people that developed the web application for the bank, they know how everything works. So they know that when you click a button, they actually know the exact post request that gets sent, the exact structure. So very similar to, that part is very similar to what we did in the cross-site scripting lab. So they know that. So they know how to craft that. But the problem is they can't just send that to your bank pretending to be you, right? Because what happened would, and remember, this is something that you guys are doing for your term project, right? Remember that part of the requirements of the term project is to create a login. So as you know, when you have a login, what you do is you download the page on your client machine, type in your username and password, that gets sent encrypted to the server authenticates something in the database, and then it sends you an ID, and that is stored in a cookie in your machine. And that's called the session ID, and you use that session to authenticate, and it's stored there. Then as you are in your bank, you click on this button, that button, start navigating, and every time you're clicking things, you're already authenticated, so you don't have to authenticate again, and therefore you just send, every time that you click a button, you make a new post request, and you just send the session ID from your cookie. That's what the browser does. You're already authenticated, you have same origin, no problem. So what happens with the cross-site request forgery, to go back to the example, you're on the corner office of the 50th floor. The people that are attacking you know how to craft these requests. So what they do is they know that you have logged in. They see you, they've been watching you all day, waiting for you to log in. They know that you're gonna be logged in between 5 and 10 minutes because you're gonna be doing some transactions. They've been monitoring you. The second you do that you log in, they notify their own people, and they know also that you're logged into your email. And as you know, people can reach us on our email addresses, right? That's one thing that email can do. And so they immediately craft a very smart email, and they send it to you. So as you're doing your transaction in your bank and you're logged in, you receive that email. And it's an email, obviously this is the part that's a little bit like social engineering, phishing, right? So that, that's a different problem, but let's assume they know you very well and they crafted a type of email that you can't resist. So the second that email comes in, you immediately, by mistake, you open it and you were tricked into something and clicked. The moment you click on whatever that is on the email, a new page opens. That's a link, right? And you open you download from some service, from some server, let's call it bad website. And you download it to your client. And now on your browser, guess what? You have 3 websites open: your email, your bank, and the bad website has opened. And that can be even, it doesn't really matter what the bad website shows you. It might actually show something that you believe to be good or trusted. But the problem is when the page load, remember, it's got JavaScript, it's got a form, it's got something that allows it to unload, grab some JavaScript functions maybe, or grab some HTML forms, or even a very simple image tag. It depends on the type of target, and it's going to open up that, and it's going to initiate, because now the key thing is they know that you're in that bank, so they're going to initiate the equivalent of whenever you go to your bank and let's say you want to transfer money and you click on a button, well, that translates into a GET request, right? That is encrypted via your browser. We learned that it gets encrypted with SSL, but that's the responsibility of the browser to do that. But unfortunately, what's going to happen is that GET request gets into the encryption pipeline, but before it gets in there, it's exactly as if it came from that version that you have in your client of the bank, and the browser, unfortunately, believes, it doesn't really know that it was generated by a bad site. It thinks that it was generated by you, and therefore it attaches to that GET request your session ID from your cookie. And at that moment, the attacker has successfully sent from your computer with your session ID as you are logged in, the equivalent of you, let's say, pressing a button on the bank site to transfer, all your money to some other account. And that's it. That's the story. That's CSRF. Does that make sense?
Yeah.
Okay, you guys understood then? No questions on CSRF?
No, I don't think so.
All right, good, good. All right, so that's, you know, so obviously there's more to it, more details, but in essence, that's the explanation of what CSRF is. That's the cross-site request forgery attack, okay? So obviously a lot of elements need to happen. And that's why, again, let's begin here. So now probably, now that I've said all of that, hopefully you guys understand what it means that a CSRF is an attack that involves a victim user, that's you in the corner office, a trusted site, that's your bank, you were logged into it, and then a malicious site, and that's when you received an email and you clicked on it, okay? And so that's really the idea. So then now we can drill down into the specifics of this. So first of all, the victim user holds an active session, right? So the victim user holds an active session with a trusted site and simultaneously visits a malicious site. The malicious site then injects an HTTP request. The lab will include examples of both GET and POST, but it injects an HTTP request for the trusted site, using the victim's user session and therefore compromising its integrity and its authentication. Okay. So the lab. In this lab, you will be attacking a web-based message board. So not a bank, but a message board. But it's the same thing. It's a similar message board that you've been using all semester. You're going to log into it, obviously. You have to be logged in for this to work. So you're going to be attacking a web-based message board system using CSRF attacks. The open source message board application is called Ph.D, and it has been modified to make it vulnerable to CSRFs or CSRF attacks. The original application has implemented several countermeasures, right, for avoiding CSRF attacks. As part of the lab, you will need to research, basically audit, and this is something also, again, that you should be doing for your term project. Make sure that there are no CSRF vulnerabilities. So you will need to research, audit both sites, and identify what changes have been made between the original and the vulnerable sites. Now this is provided in the lab and I have it here, right? So this is the original site without the modifications. This is the vulnerable version of it. So the countermeasures have been turned off. And this is your attacker site. So when you do the attacks, you inject the code there. And as far as identifying the countermeasures, you're going to have to audit both of these sites so that you can find the countermeasures. So if you notice here, you've been provided with the URL and also where the files are located on the seed Ubuntu VM. So a little bit more background on of CSRF attacks. So a CSRF attack always involves the three actors: a trusted site, a victim user, and a malicious site. The victim user simultaneously visits the malicious site while holding an active session with the trusted site. So I just described that very scenario. Now let's look a little bit at the sequence of steps that must happen, okay? So first, the victim user logs into the trusted site using his username and password, and thus creates a new session. Then number two, the trusted site stores the session. So keep in mind, so one thing I will stress, remember that you guys are building your login for your project, right? So think about this cross-site request forgery so that you implement your login in a way that does not permit this to happen. So the victim user logs into the trusted site using his username and password and thus creates a new session. Number two, the trusted site then stores the session identifier for the session in a cookie in the victim user's web browser. Then number three, the victim then visits a malicious site. So for instance, an email arrives at the moment. Number four, the malicious site's web page then sends a request to the trusted site from the victim user's browser, pretending to be the bank's client website, but it's actually the malicious. Obviously, they need to know, the malicious attackers need to know how the bank's website on the client side issues all the GET requests and POST requests. When that happens, the web browser then automatically attaches the session cookie to the malicious request because it is targeted to a trusted site for which it has a cookie. Now, a couple of things to think about is the origin of something, right? So if you're logged in to Facebook and then the page Facebook where you press buttons should have a token that Facebook provides or an origin that says this came from Facebook. And hopefully there's some kind of a built-in option for that. The malicious site will not originate from Facebook, obviously the Facebook page, but from a malicious page. Then number six, the trusted site then processes the malicious request forged by the attacker website. Now they might return the response to the good site, but the goal of the attacker is just to get whatever commands they're sending to the server for them to execute, such as wire transfer the funds to this offshore account or something. Okay, so that's the idea. So now in the lab, you're going to practice a lot of things. In particular, you're going to be doing this, for both GET and POST requests, just to kind of practice. The ones that are for GET requests are a lot easier than the ones for POST requests, but they're both doable. So the malicious site can forge both HTTP and POST requests for the trusted site. And the GET request can be as simple. So for the GET request can be as simple as just IMG, right? Once again, IMG. Look, people are exploiting that again. So some HTML tags, such as IMG, iframe, frame, and form, have no restrictions on the URL that can be used in their attribute. And that's really the advantage because you're going to plug that in the attack, right? So some kind of redirection. In fact, HTML, IMG, iframe, and frame can be used for forging GET requests. As far as the POST request, we're going to have to use the HTML form tag, which you guys know from your 110 and 362 classes. You know how to create forms. And those can generate the POST requests. So the tasks in this lab involve forging both GET and POST requests for a target application. I think there's about 3 problems, as you might expect. One is GET, one is POST, and the other one is the countermeasure. So this is a straightforward lab, I think. Okay. All right. So let's take a look at this diagram here. So here we have how, basically we want to recall how sessions work and how to use cookies. So you have 2 parties, the browser and the server. The browser and the server. So this is not even considering the attack. It just, it's basically how things work. So from your browser, right, you open up a page, you do a post of a login, saying you're logging in there, right? Then the server is going to reply to you with, the authenticator for the cookie. Then you can then proceed and make requests, right? Using that authenticator. Every time that you communicate with the server, it'll be attached to it, and then you will get, your response, right? So that's the pretty much straightforward approach of the client-server architecture. You're all very familiar with that. So now with the cross-site request forgery, let's think of an example of this. So we have, the bank, right? So I gave you this scenario. So the user logs into their bank, and let's just say it's bank.com. So obviously a session cookie remains in browser state, right? So that's how you keep track that you're logged in. Then the user visits another site, a malicious site, and the user doesn't know that it contains this code over here. And if we analyze this code has a lot of things in it, right? So it's got some JavaScript, for instance. So it is a form, which means it will allow us to generate a post. The action is to go to your bank. Notice that it's going to go to your bank, but from the malicious site. Okay? And then, you have some input, some data there, and then finally, it's got some JavaScript, right? And that JavaScript then does what? It does. Notice that the form is called F, right? So that way you can use the document object model to reference that element. And then you can say with the script over here, you can say from the DOM document.f. That way you're referencing this form itself. So the script is referencing itself, and it's saying document.f dot submit, right? And that's the key aspect there, because now you've submitted the form itself. Where do you submit? You submit to the bank, and guess what? You're logged in, so the session will be attached to it, and you're in trouble. So the browser sends the user authentication cookie with the request, so that the goal is for that whatever that transaction is, whatever they said here. Here it says bill pay, but maybe it says withdraw funds, right? Something like that. And so that the transaction will be fulfilled. And that's not a desirable thing. That's not actually what you would want to happen. But that's how you measure that your attack was successful. So the problem is that cookie authentication is insufficient when this happens, right? So that's why we're going to see that additional things would be to have secret hidden tokens in the page, in the bank page itself, that change constantly. So these are tokens that would change every day, etc. And so that way, because this is coming from another site, they wouldn't have access to that information, right? So that will be one of the countermeasures. So now we can think about the basic picture of so now the basic picture, basically, we can think of it again through the client-server architecture. So you're in your corner office on the 50th floor. You're the user victim. This is a bank. The bank. So you're logged in to check. You got paid today. You're checking your pay, and you establish a session. That's number one. Okay, so you've got the established session. Then you receive an email, and that email makes you go to another, attacker server. And then the attacker server then that, sends to your browser, the page, serves the page. So you receive the malicious page. But this malicious page, what it does is it forges, because it already knows how to do that, it forges the types of, post requests that the bank accepts, right? Because it's gonna have something that looks like that one. So it's going to then receive the malicious page. And now when the malicious page arrives in your browser, in your Firefox or Mozilla or whatever, remember it has some JavaScript in there. And the JavaScript just basically says, submit me, but submit me from the client. So it's gonna now, the browser then goes ahead and submits the request. So sends what is called a forged request. And guess what? It attaches your cookie from your pre-established session. And now if that request, whatever it is, maybe it'll be like, withdraw funds from over here. And so now you're in trouble because the bank believes it came from, think about it, for the bank, geographically, where did it come from? Came from your machine. What browser did it come from? Came from your browser. Did it have the cookie as you were logged in? I mean, you're yes. And that's it. So you see how that would work, guys? That's the basic idea, or, as this slide indicates, the basic picture of the cross-site request forgery. So think of this little question over here. How long do you stay logged onto Gmail, right? During the day. That's why banks, if you have a bank online, if you notice, they're constantly trying to log you out, right? They're the service that always tries to log you out, right? Because as long as there's no session, there's no problem. Any questions?
No.
All right, so let's take a look at this one. Let's look at this example. It's very similar. Just another way of looking at the same thing. This is based on a form post with cookie. So the victim visits it. You assume already that they're established the bank. Session is in the browser. The victim browser then visits attacker, a blog or something. The attacker then serves the page contents. Which if you notice, it's going to contain the form, very similar to what we just saw. Notice here the idea is captured of bank transfer for, to recipient attacker, and in the amount of, is it $100? And so that's basically what gets sent back from the server back to you, the client. Then here at the client site, right, in this is basically, this line represents your browser. That's your browser. So now your browser is going to execute this one because of that JavaScript there, make this action or take that action and attach to it the cookie. So you can see here, the form generates a post request over there, right? And then the refer is going to be attacker. Notice that a post request can have something called refer. And in this case, it says attacker. However, what it should say is bank.com, right? So that already is an indication that there's a problem. But some websites can validly visit other websites, right? So that's the problem, that, like embedded Facebook inside another website, right? That happens, right? YouTube, you embed within, web pages and so on. So So that can happen. It's not necessarily wrong, but the referrer does already give you a hint that there might be a problem. And when it comes to a bank, certainly the referrer should be the bank. You know, the bank should not be embedded inside anything else. You know, it should just be, you know, because it's a very serious thing, right? And so, but, you know, be aware of that. And then after that, it just includes the tokens that they want, right? And, but unfortunately, the cookie has been appended here. So it sends that to the server. The server thinks, okay, you know, that valid cookie, valid origin, so transfer funds, right? And that's basically how that works, okay? So that's CSRF. So the whole lab is just this one concept. It's not like there's several concepts. There's really just this one, and in particular that we're gonna have to do this in both GET request and POST request format, okay? All right, so now this can be applied also if it was like a cookieless example. So in the sense when you don't need a cookie, right? That's even easier to implement then. So you just, but it's the same principle. You know, you're configuring a router, you visit a malicious site, receive the malicious page, and then from your browser, you send a forge request. So the router just thinks it's you, and then you can do, you know, all kinds of things. Question? No? All right. Okay, so that's basically the idea. And now what we have left is just we're gonna go over some of the details of this, a few other details, and then after that we will be ready to start looking at the PDF lab for this session. So now that we've looked at all the diagrams and we hopefully have a better understanding of how this works, let's just read through some of these comments. All right, so XSRF or CS, I'll be using interchangeably. So in the exam, you might see me write XSRF or CSRF, but I do mean cross-site request forgery. So it's a type of, so in summary, it's a type of malicious exploit of a website whereby unauthorized commands are transmitted from a user that the website trusts. Unlike cross-site scripting, which exploits the trust a user has for a particular site, CSRF exploits the trust that a site has in a user's browser. So remember, here is about the web browser, the cookie in the web browser. So the attack works by including a link or script in a page that accesses a site to which the user is known or is supposed to have been authenticated. For example, one user, Bob, might be browsing a chat forum, which is what you'll do in the lab, where another user, Fred, has posted a message. Suppose that Fred has crafted an HTML image. So this is the example of the GET request. So has crafted an HTML image element that references an action on Bob's bank's website instead of an image, right? So there's no actual source image that you're going to retrieve. Instead, you're just, the source is the command that you want to do. So for instance, here, the IMG tag is provided there. And then, but in the source, you can see it's actually bankexample.com. And then what do you want to do? You're going to go to the withdrawal page and for the account, Bob, and look at, you know, that's a lot of money, right? And so you're going to send it to Fred, right? So that this is a simple abstract example, but it's, you know, it's the idea, captures the idea. if Bob's bank keeps his authentication information in a cookie, and if the cookie hasn't expired, then the attempt by Bob's browser to load the image will submit. So then the attempt by Bob's browser to load the image, will submit the withdrawal form with this cookie. Look at how that works, basically. Thus authorizing a transaction without Bob's approval. Okay, and it'll happen really fast, so probably before Bob can do anything. That's why sometimes websites provide like an additional measure. Like it might send you a text message. They might, at least on the website, give you a pop-up window where you have to, are you sure you want to do this transaction? So that kind of thing. That's sort of the idea for that. A cross-site request forgery is what is sometimes called a confused element attack against a web browser. So the element in the bank example is Bob's web browser, which is confused into misusing Bob's authority at Fred's direction. Now, the following characteristics are common to CSRF or XSRF attacks, right? So basically, they involve sites that rely on a user's identity, right? Being logged in, user. And it exploits the site's trust in that identity, in the trust in the session cookie. So obviously, you know, the solution to this is to have more than just a session cookie to authenticate people. And as you will see when you do your lab, you're going to find out that there are, in fact, additional parameters that you set up that the malicious site cannot retrieve. And also, finally, trick the user's browser into sending HTTP requests to a target site. Is that coming from my computer? All right, so where were we? So at risk are web applications that perform actions based on input from trusted and authenticated users without requiring the user to authorize the specific action. So that's what I was saying. So it's sometimes good and bad in action, but then to have to kind of authorize, are you sure, you know, that kind of thing. Are you sure that you want to do this transaction, etc. A user who is authenticated by a cookie saved in the user's web browser could unknowingly send an HTTP request to a site that trusts the user and thereby causes an unwanted action. Okay. CSRF attacks using image tags are often made from internet forums. So that, you know, that's when you visit an internet forum and you see like what looks like a broken image link, right? You know, that could be an indication that, well, there's no image that was retrieved. Instead, whenever you open that, what it does is instead of the HTML page loading the image, it's going to try to do the request, right? And if they knew you, or if you're logged into that message board, for instance, then they're going to pretend to be you in that message board. So that's a common attack. And that's really what you're going to be doing in the lab. So it's like you're going to be impersonating someone else. So this is, so as this says, so CSRF attacks using image tags are often made from internet forums where users are allowed to post images, but not JavaScript. So that could work as well. So CSRF attacks are often exploited in pair with XSS attacks, and that makes CSRF vulnerabilities much more dangerous. Imagine now combining cross-site scripting with cross-site request forgery. So that can give a more powerful attack. So CSRF is actually a tough attack to get to succeed. But then again, you only need to succeed once, right? So as you will see in the lab, it's not going to be so trivial to get this one to work, but at the same time, it is, perfectly doable. So here, the attacker must determine the right values for all the forms or URL input. So that's the first challenge right there. You have to really know the form really well, right? What are the text boxes that need to be in there? Does the form have hidden parameters that, are changing constantly as they come from the server? Little things like that. So those are usually helpful, those tokens. So the attacker must determine the right values for all the forms or URLs inputs. If any of them are required to be secret, authentication values or IDs that the attacker can't guess, obviously the attack will fail. And that is basically one of the countermeasures, or the main countermeasure that you have available in CSRF, or that type in essence. So the attacker must lure, and another problem is, obviously, as I said, if you're in the corner office and you're on your bank, you also need to have your email open, for instance, so that they can lure you, right? So the attacker must lure the victim to a web page with malicious code while the victim is logged in to the target site. Okay, so that's another piece of this. So here are some of the defenses of CSRF as we have as we have talked about this. So one of them is the one I've mentioned, the secret validation token. Usually it's just some type of an input in the form, type hidden, and this parameter is something that the server is changing constantly. Okay. Refer validation, we already saw that a couple of minutes ago, and we saw that whenever you make these HTTP requests, the request actually can have a field called refer, and that's usually what domain, obviously when you download a page to your client from the server, it's basically you're downloading that domain name is there, and so that domain name gets added into the refer field of this new request, okay? And so that's really the idea here, is that you have a refer, and then the refer is gonna be something like, Facebook or whatever, bank, or the malicious attack. So that's another way of, sometimes, measuring or providing defenses for cross-site request forgery. Other things are like custom HTTP headers, like Google, for instance. Obviously, as you might imagine, all browsers are constantly working on these things. So Google may have other specific fields in there that they're changing constantly to provide this kind of security. So any parameter, really, definition would be any parameter that cannot be guessed by the attacker, but that is required in the form, would be a really good defense. So some CSRF countermeasures used by websites, as we've seen already quite a bit, requiring a secret user-specific token in all form submissions. The attacker's site cannot put the right token in its submissions, and therefore it's not going to work. Requiring the client to provide authentication data in the same HTTP request used to perform any operation with security implications. So obviously that, that's important one, like confirming, okay, please log in again before this goes through. That's certainly for high security. And also an important one, limiting the lifetime of session cookies, certainly. You don't want, that's why your bank closes, really quickly all the time, and so on. Okay, are there any questions so far? Okay, doesn't sound like there's any questions. Good. So we're almost done with the slides, and we'll be ready then in a sec to get into the PDF for this week, or for the lab. So the secret token validation, basically requests include a hard to guess secret, right? Unguessability substitutes for unforgettability, right? So the key thing is it's something that's hard to guess, so some parameter that gets generated by the server. This could be a session identifier, session independent token, and that's actually a good one. So it's a token independent from the session, some variant of that. You can see an example of that here. So here we have a secret token validation. So, you might remember this from your 362, your 110, right? You have a form, some website. And then this is obviously a form. And then you have there like some fields, and you have, a button. But what's important is that as part of the form, you actually have a variable, which is an input. It's called authenticity token. Probably don't call it authenticity token. Type hidden, and then in there, there's some kind of a token that is being used for that day or that hour even by the servers of the company. And so that is something that the malicious site will not, would not maybe be able to get that token because it's pretty large to guess it, right? All right. The refer validation, we already talked about it. So you kind of saw that as well. So, first, you can see the login there. It says for Facebook login, for your security, never enter your Facebook password on sites not located on facebook.com. So this used to be more common, 5-10 years ago, I think. People would love to embed things within other pages. And if you notice, that tendency has changed. I don't know, you guys probably use the internet a lot more than me for social media, but it used to be like that you'd like to create websites and embed things within them, but now a lot of things are standalone, and it's sort of this idea of the refer validation, for instance. So as you can see, the main idea with the refer validation is what page originated the request. So in the refer header that we saw in the HTTP GET or POST request, there would be a field called refer, which could be blank. If it's going to Facebook and it's Facebook, then that's good. Obviously, if it's going to Facebook but it says attacker or something else, you would want that to be blocked. However, refer, as I said, it's not a strict thing that has to be, it is possible for a valid page to generate a GET request for another page. And so really what browsers sometimes have done in the past is that they had a policy that for some sites that are very sensitive, they had very strict refer validation. Whereas for other sites that were not very important, they had very lenient refer validation. So in this case, we can see lenient refer validation does not require if referrer is missing. Whereas for strict referrer validation, it's highly secure, although referrer is sometimes absent. But the idea is that, you know, the stricter it would be, it's not going to approve anything unless that referrer domain matches the servers. Plus, it should have the token plus the session cookie. So you do a combination of all of these together. But as part of your lab, although I've hinted at these during the lecture today, in your lab, you guys will explore these, okay? Explore these, do a little bit of a search there and find the answers. So recommendations, so HTTPS sites, you know, that are encrypted, such as banking sites, should use strict refer origin validation to prevent CSRF. Okay, that's, you know, basically use strict. Other sites implement secret token. There's also an origin header, which is an alternative to refer with fewer privacy problems. And so on, right? So there's a lot of these. Browsers are constantly, you know, trying to improve these issues. And that's it. So that concludes the lecture slides, or the slides for CSRF, cross-site request forgery. So now we are ready to go to the lab. So I'm going to go to the Seed Labs website, just double checking that I've already posted the PDF on Brightspace, but I just want to confirm that they're constantly changing these labs. So I want to make sure I have the latest one. So if we go to web security, so you should be seeing, I think, oh, sorry. Okay, so I'm sharing now the website. So as you can see, you should be seeing in the website cross-site request forgery. That's this one. I believe this lab hasn't changed. We're using Seed 1604, so that's good. And I think this is the one that's posted on Brightspace. So you can see the 2006-2016 version, and it's called cross-site request forgery with the. Let me make this a little bigger. So it is this. This is the lab. We're going to use ELG again. Remember, ELG is just a framework we've been using. It's very framework that allows you to easily develop social media sites, like your own Facebook type of a thing. But it's at the end of the day, like your term project is just PHP, MySQL, jQuery. So here is the lab. So let's just take a quick look at it first. So you can see it's got the overview, some information there. I'll go over that. There's the specifics of the environment. Then it's got the lab tasks, obviously. So task number 1, just observing a normal HTTP request, then with live HTTP headers, which by now you should be familiar with. Then we've got the CSRF attack using a GET request. You know, as I said, you're going to do that one with like IMG tags and so on. Then you have the post request, which will require you to implement this with forms, because that's the only way that they work. And you can see the code is provided here of what you would see in the live HTTP headers. In particular, you probably want to look at, host here. You want to look at refer. The field is there, and notice what it shows. Notice there's the cookie that was taken from document.cookie. And notice here there's a few things like description, location, all the parameters. And you have the famous ELK tokens, right, that were for security reasons. So these are equivalent to those hidden parameters that we've been talking about. So everything in there has, importance, obviously. Okay. And then that's just what you would see on live HTTP headers. But remember that you usually have to craft your request based on this, but you have to plug it into something like this. Okay. So here, we're going to see that it's an HTML page. You got your JavaScript here. Notice it's a function get post. And then if you look, this will craft from some variables. You're going to piece together a string. All right. And then once you're going to use the document object model, notice here you're creating a form. Okay. So I will, guys, my internet is saying it's unstable. I don't know why today I've had bad internet, it seems. So if I cut out, I will have to generate the video and then I'll come back, okay, in case it breaks. But just be aware of that. Sorry, that causes problems. So what I was saying is besides getting those variables, we also, through DOM, create a document element called form. So basically, it's like we're writing a form, but through DOM. And then we specify that the inner HTML of that form should be fields. So remember how we did dynamic, dynamic development of an HTML page through the document object model. So that's, a topic of 110 and 362. All right, and then finally you submit the form over here. So you submit the form, and that's it. Then obviously when on the window.onload, you call the anonymous function, and then it calls forge post, which is this function, and then it executes that effectively. You'll have to answer these questions, and then, as I said, implementing the countermeasures. So you have to do a kind of a read through, right? But it's the ELK tokens. That's really the secret there. And then after that, you can just read through all this information here about the session ID. In particular, this can help you as you're developing your own login, right, for the e-commerce term project website. And then after that, you can read through this about the countermeasures. And then there's obviously the guidelines, same as before. How does live HTTP headers works? You already know how to use that from the previous lab. And some information about debugging with JavaScript, and then the submission standard approach. So really, first, I kind of wanted to do just a brief overview of the lab. So really, for this lab, you're responsible for the whole thing. Okay, so you're responsible for the entire lab. This one will be due. We're gonna say. So actually, before I forget, and then I'll come back to the PDF. Let me switch over to. You should be seeing the bright space over here. Let me just switch courses. I think cool. All right, so this week then I'm now in the bright space environment in CSRF. That's today. See, I know I already loaded the PowerPoint and the ELK. Pretty sure this is the same one. Double check, I guess. Yeah, it's the same one that I went through just now. And so all I'm going to do is I'm going to add a new assignment. This is your last assignment, as I said, for the semester. Due next week. Well, actually, next week is Thanksgiving, huh? So let's think about that. So this is going to be the CSRF homework. So the 20, today, no, what day is today? Well, yeah, so this lab, even though we're starting it today, it would technically be assigned on the 19th, which would make it due on the 26th, but that's Thanksgiving. It's really the last lab, so I'm just going to give you one more week. So then, so it's going to be due on the 3rd of December, which, by the way, is the last day of class, I think. No, it's not the last day of class, but it's almost the last day of class. So I'm going to make this due at 11 p.m., which is 10 Central. And end date, just leave it open until Saturday. All right, that's your lab. All right, so I'm giving you there, yeah, so I've created the assignment, and this one should be a lot of fun. As I said, you know, during labs, ask me questions, right? So if you want me to help you with something, there's the link has been created. All right, any questions so far?
Nope.
Questions, wow. All right. So let's then dive into the lab itself. Okay, so I think, you know, hopefully it's clear. I've explained it. But let's just go over the problems just a little bit more specifically, and then that will be, you know, the lab will be technically assigned. So the objective of this lab is to help students understand the cross-site request forgery attack, CSRF. A CSRF attack, as we've discussed, involves a victim, a trusted site, and a malicious site. The victim user holds an active session with a trusted site while visiting a malicious site. The malicious site injects an HTTP request for the trusted site into the victim's user session, causing damages. In this lab, students will be attacking a social networking web application using the CSRF attack. The open source social networking application called ELG is being used, as we've been using all semester. And this has already been installed on your CBM. ELG has some countermeasures against CSRF, but they have been turned off for the purpose of this lab. This lab covers the following topics: cross-site request forgery attack, CSRF countermeasures such as the secret token and same site cookie, which you can see as another cookie value. And then it's going to cover HTTP GET and POST requests and the use of JavaScript, basically. All right, so now readings. Obviously, you can read this in the book. There's a detailed chapter in the book, chapter 10 of the Computer and Internet Security book, second edition. So definitely read through that one. Should be a lot of fun. This will be done in the Seed Ubuntu 16.04. Basically the same thing. There's going to be some accounts. You've used these before. Have to log in, have the password. Here is the URL, right, of the attacker and of the victim, and the location of the file, so you can explore the files in there. You don't have to worry about any of this. This has already been done for you. And then really you just have to, if Apache is not running, start it and then start the lab. So let's take a look at the lab tasks. So here we have, for the lab task, you will use two websites that are locally set up in the virtual machine. The first website is the vulnerable ELK site at csrflablg.com. The second site is the attacker's malicious site in ELK. This website is accessible via the CSRF lab attacker. So that's really where you will have to somehow inject your code, right? Your attack code needs to go in the attacker site. So the first task, task 1, will be to observing an HTTP request. So in cross-site request forgery attacks, we need to forge HTTP requests. Therefore, you need to know what a legitimate HTTP request looks like and what parameters it uses, okay? So you can use the Firefox add-on live HTTP headers, which by now you should all have since you've done the previous lab. The goal of this task is simply to get familiar with the tool, and instructions on how to use it are in the guideline below. So please use this tool to capture an HTTP GET request and an HTTP POST request in ELK, by pressing buttons or whatever. And in your report, please identify the parameters used in these requests, if any. Any questions about task 1?
No.
All right, I don't hear any questions. So task number 2 is now the CSRF attack using the GET request. So here in this task, we need 2 people in the ELK social network. Let's say Alice and Bobby. Bobby wants to become a friend of Alice, but Alice refuses to add him to her ELK friend list. So Bobby decides to use the CSRF attack to achieve this goal. He sends Alice a URL via email or a posting on the ELK site itself. Alice, who's curious about it, clicks on the URL, which leads her to Bobby's CSRFLabAttacker.com website. So now you're going to pretend that you are Bobby, describe how you can construct the content of the web page so that as soon as Alice visits the web page, Bobby is added to the friend list of Alice. This, of course, assumes for CSRF, remember, Alice needs to have an active session with ELK, okay? So you'll have to think about this one a little bit and solve it. To add a friend to the victim, we need to identify what a legitimate add friend HTTP GET request looks like. And of course, as you might know, you will use live HTTP headers for that. In this task, you are not allowed to write JavaScript code to launch the CSRF attack. So your job is to get the attack successful as soon as Alice visits the web page without even making any click on the page. So the hint, as you might imagine, is to simply use the IMG tag as we described in this, because you know that an IMG tag will automatically trigger an HTTP GET request. So ELK, as we've also discussed, has implemented a countermeasure to defend against CSRF. So for instance, in the add friend HTTP request, you may notice that each request includes two weird looking parameters, which are LTS and L token. And you've seen those in a lot of the labs before. These parameters are used by countermeasures or as countermeasures. So if they do not contain correct values, the request will not be accepted by ELK. But this has been disabled in this lab, so obviously those parameters. So there's no need basically to even include those parameters in your attack. All right, and that is task number 2, which is a CSRF using GET request. Okay, so use the IMG tag. All right, the next one is task number 3, CSRF attack using the POST request. So whenever you hear POST, you remember, oh, I'm going to use the form. Remember, these are the types of questions I will also ask you in the exam, right? So little things like that are easy questions to ask. All right, so now task number 3 is the CSRF attack using the post request. So after adding himself to Alice's friend list, Bobby wants to do something more. He wants to say, Bobby is my hero in her profile. So basically, this is the equivalent of, modifying that profile somehow, updating it. So everybody knows about that. So Alice does not like Bobby, let alone putting that statement in her profile. So therefore, Bobby plans to use a CSRF attack to achieve that goal. And that is the purpose of this task, which you then have to craft. So one way to do the attack is to post a message in Alice's ELG account, hoping that Alice will click the URL inside the message. This URL will lead Alice to your Bobby's malicious website at attacker.com, where you can launch the CSRF attack. So obviously your code will need to be in there. The objective of your attack is to modify the victim's profile. In particular, the attacker needs to forge a request to modify the profile information of the victim user of ELG. Allowing users to modify their profile is a feature of ELG. And so with live HTTP headers, you can see what that looks like once obviously you fill in a whole bunch of text boxes in a form and you click a button, right? So you need to capture that. If users want to modify their profiles, they go to the profile page on ELG, fill out a form, and then submit the form. Sending a post request to the server-side script, this one, edit PHP. So it's very critical that you actually look for this script and you analyze it. Is this then which processes the request and does the profile modification? The server-side script edit.php, the server-side script edit.php accepts both get and post requests. So you can use the same trick as that in task 1 to achieve the attack. However, in this task, you are required to use the post request. Namely, attackers, you need to forge an HTTP post request from the victim's browser when the victim is visiting their malicious site. So attackers need to know the structure of such a request, obviously, and that's going to be the hardest part of this problem. So you can observe the structure of the request, i.e. the parameters of the request, by making some modifications to the profile and monitoring the request using live HTTP headers. You may see something similar to the following, and you can see that here. So notice in particular, it has to say it's a post request. Unlike HTTP GET requests, which append parameters to the URL, the parameters of HTTP post requests are included in the HTTP message body. Okay, so they're going to be in the message body. Okay, and see the contents between the two symbols over here. So this is, the 2 star symbols, right? So that's the body. Oops, just between the stars. After understanding the structure of the request, you need to be able to generate the request from your attacking web page using JavaScript code. So that's the second part of it. To help you write such a JavaScript program, the code is provided for you. You can use the sample code to construct your malicious website for the CSRF attack. This is only sample code, and you need to modify it a little bit. But from your knowledge of 110 and 362, it should make sense. This is just the standard HTML stuff in a page, your JavaScript tags, the function forge post, have a whole bunch of fields that will contain, notice, hidden parameters, name, descriptions, etc. And then finally, you'll create, so you'll have fields as a concatenated string, and then you create a object P, which is initialized as a document.createElement form. So you initialize a form, you're going to provide the action for it. Obviously, this is going to change. It's not going to be example.com. You should know what it should be. the inner HTML is going to be what you collected in fields, and then you just specify that it's a post method. Post method, okay? And then finally, you append P to the document, to this same document in the body, right? So basically, this is just appending all this that you created is appending it to the same object, and then this will submit the form, and that's it. Whenever the page loads, it'll run the function and do everything. All right? Any questions?
None so far.
So far, all right. So that's it. That's the lab. I think you guys can read the rest of it. If you have any questions, let me know. But you know that's basically the last main topic of the semester, CSRF. This lab is due a week from Thanksgiving, I think. So remember on Thursday, very important. We're gonna meet, and you guys will. We're gonna do this breakouts with soon, and I'm going to be moving between the groups so that you can demo what you have, okay? Or would you rather we do like everyone sees everyone's work, just so that you guys get a feel for where everyone is? What would you prefer? Would you prefer the breakouts? Because those are, when you're in a breakout, you really can't see what another group is doing. Or would you rather do, you know, like an open everyone? What would you prefer? Guys, are you there?
Yes,
I would almost say doing it with everybody as one so that we get an idea of where everybody's at.
Okay, that actually, when I said it, I thought about that too.
Yeah, I was thinking the same thing. I feel like no one was just like.
Yeah, because it helps you to see
out.
where they struggle and possibly what they've solved and everything. Okay, yeah, that works. That's a good plan. As I said, I like to do these to keep everyone on track and to reinforce. Also, if you can bring your reports that you've already started to do and your testing that you've already started to do, I like to take a look at all of those. So this time around, I'll be looking for code, demos, your reports, and your testing results. I think the last time around, only SAC's group had a report. I can't remember, but I feel that was the case. So this time around, though, everyone, please have that. And as I said, that way we can all take a look at it. I can give you feedback, and then you can see if you're falling behind or not. Okay. All right. That sounds good then. Okay. So as I said, the rest of the lab you can just read. That's basically the lecture for today. So let me pause the recording at this time.